Hi, everybody. Jeff Marr with STEM School Highlands Ranch, and joining me is Will Santiago. And Will has an awesome job working as a deep space exploration engineer for Lockheed Martin. Will, we're so thrilled to talk to you. Thank you for making the time.
Thank you for having me, Jeff. Good morning.
Now, we're going to talk to you about a number of things because you serve as a mentor to students at STEM School Highlands Ranch. We have a lot of students who go into the engineering program and they have dreams of eventually having a role such as yours. We're going to talk about that in a minute. But first, I want to talk about some of the projects that you have worked on because you have over 10 years of experience working on multiple human space flights and robotic exploration programs, most recently serving on the spacecraft development team for NASA's Lucy and Lunar Trailblazer missions. And because Lucy just had that successful launch, congratulations, by the way, we wanted you to talk about that particular mission, your involvement, and for those who don't know, if you can just kind of summarize the mission and what we can expect out of it.
Yeah, thank you, Jeff. Yeah, so Lucy just launched this October 16th, and it's NASA's first mission to the Trojan asteroids that are these swarm of asteroids at Jupiter distance from the sun. They're in this tug of war and gravitational stability in front and behind Jupiter, but they're really far away from the planet, actually. And it's the first spacecraft ever to explore these objects, and they're basically the remnants or the fossils of early solar system formation. So by going up close, we're hoping to learn more about the origin of our solar system. So the Lucy spacecraft was actually built here at the Lockheed Martin Space Facility in Colorado for a NASA Goddard customer. So the Lockheed Martin team was the integrator for the entire spacecraft, along with the instruments that were provided by different institutions and universities. So we started, I want to say, building the Lucy spacecraft about 14 months kind of from launch. It actually took over 7 years for the design and development of the spacecraft, and I was part of the spacecraft team as a mechanical engineer, as part of the thermal team, and planning some of the environmental testing. So yeah, Lucy is a 12-year mission, record-breaking. It'll visit 8 asteroids in just one mission, but it takes a while to get out there, so it's going to be a 12-year. And we're going to be responsible here at Lockheed too for operating the spacecraft for NASA as well and supporting to get this super awesome science.
Now, in terms of your role, getting the spacecraft launched, is that where your role ends and you focus on another project, or do you revisit this project 12 years down the road when some of that research starts to come in?
Yeah, so it varies for all of us. I started the Lucy mission back in 2018. So right before we were working on our preliminary design review, doing all the presentations, checking out that we had the right requirements for the design of the system. And then fast forward, I ended up leaving the team about June, just before launch, to work on this next mission, Lunar Trailblazer. And it was right after my last task there was developing our longest environmental test, where we just take the spacecraft through a thermal vacuum, freeze it, bake it, just try to stress it before we send it out to space. And then I moved on to Lunar Trailblazer, but I was fortunate enough and lucky enough that I was out there for the launch and was able to see the team and help out with a few STEM outreach events and talk to the public about the cool mission of Lucy. So now I'm working on Lunar Trailblazer, and we just got through our preliminary design review, critical design review, and we start building that spacecraft here next year, actually in June.
Now, I'm just curious, when you work on a project like this and so much time and effort and money is put into it, are you pretty much holding your breath along with the rest of the team during that launch? Is that just a time when you really don't know what's going to happen?
Launch to me was a little bit surreal, right? Because I was working on the program for about 3 years, but there were people that have been working on the concept of the Lucy mission for well over 7, 8, 10 years, right? So it was careers for many of our science team working on this mission. It's a little bit surreal to get to that moment of launch, right? You have tried to figure out every single little detail, from the nuts and bolts to like the big solar panels that Lucy has to the propulsion system. So you're looking across everything, and you have tested as much as you can over that 14-month period when you're putting the spacecraft together, and you're, you know, trying to blast it with sound just like the rocket would, having all the testing with the vibration, because it experienced a lot of vibration during launch and a lot of stress, you know, all the mechanical stress and the structural stress, right? So we have tried to do our best, right, to test the spacecraft and ensure that it's going to survive those environments. But it's hard not to think about what could go wrong, right? That you can't get it once it's out there. So we have this philosophy of test like you fly. So you try to push the spacecraft as much as possible to ensure that it's going to be reliable and be able to support the long 12-year mission that it's out there. But yeah, you get a little bit scared every now and then, but we don't stop there. You know, the engineering team at Lockheed Martin is monitoring the spacecraft during flight for those 12 years of the mission from, you know, beginning to end. And we're fortunate to partner with NASA Goddard to be able to do this cool science.
Now, you've also been a part of some successful missions sending spacecraft to Mars. Can you talk about those?
Yeah, so you know, when I first started working deep space exploration, it was actually in the flight operations side. So most of the spacecraft were already out there. Out of here, our facility in Colorado for Lockheed Martin, we were fortunate to partner with NASA's Jet Propulsion Lab and more recently NASA Goddard. So the three orbiters, you know, the satellites that are orbiting Mars right now, sending a lot of cool data back that NASA has out there, were actually built here in Colorado. So the first one that's still operating, that holds the record, has been there over 20 years, is Mars Odyssey. So it's a part of the flight team of engineers monitoring the spacecraft, making sure it's all healthy and safe, and collecting the science that the science team wants. I was also working on Mars Reconnaissance Orbiter, which pretty popular. All the cool detail images that we're getting over the years, you know, high resolution imagery from the surface of Mars, come from you know, from orbit, come through Mars Reconnaissance Orbiter. And then more recently, Maven, that's studying the atmosphere, it got there, launched in 2014 or so, and it's been trying to understand the atmospheric properties of Mars and all that. Also fortunate that I worked a little bit on a Mars lander called InSight, that it's currently on the surface, trying to get data of like Mars quakes, as well as a lot of the terrestrial formation of our planets. So I was fortunate enough that when InSight was getting built, I was able to see it just before it got to Mars back in 2018. And then I also work on the Juno mission that's at Jupiter, so I was part of the flight team there as well, getting into Jupiter, getting into orbit. So it's been really, really cool and really crazy that I get to work with so many amazing people that have such a long history doing all these robotic missions to places that we've never been before, or trying to find out new things about where we come from in general.
And you still have many more years left in your career. I'm curious, what would be your dream mission to be a part of, or have you already been a part of that dream mission?
Wow, geez, you know, you know, at Lockheed Martin, we're being fortunate to like have this heritage of exploring almost every piece of the solar system with a little piece of components or hardware for almost any mission. I have to say that you know, being part of the mission, you know, to put Juno in orbit around Jupiter and seeing those first images of the poles that we had never seen before was definitely a dream come true. You know, we're also working on, you know, the human spaceflight side, which is where actually I started my career on the Orion spacecraft. So I think being able to see Orion fly and take astronauts back to the moon will be really cool. Although now I'm in this robotic side, but I don't know, Jeff, there's so much more to explore in our solar system that I think, you know, we'll just continue trying to like push the envelope a little bit, right? You know, Lucy's going to break records by being solar powered and operating so far away from the sun. So there's all these little steps that we get to take. And it's such a long mission too, you know, like there's students right now that are in school that might potentially be working flight operations for Lucy, who knows?
Now, as you know, at STEM School Highlands Ranch, we have our Building Ships program, which has everything to do with internships, mentorships, connections, friendships, and more to industry leaders. And it allows our high school students to be mentored by individuals like yourself who work in these amazing careers, to kind of give them a pathway to that if that's something that they want to pursue or at least learn more about. So you have been a mentor for students at STEM, and I know that you've had a lot of one-on-one time with them. What do you get out of that experience? What do you like about that experience in helping guide our future engineers and astronauts?
Oh, geez. It's a little bit of a reset, right? Like a lot of the stuff that we're doing, all these complex systems can get really hard. So there's good days and really tough days, right? But it's not until you get to talk to somebody and you see yourself back in time. I was that kid trying to build water bottle rockets back in Puerto Rico a long, long, long time ago. And to be here today and like being able to see a launch is just surreal to me. So I was one of them. And I see myself in all these students, and I didn't have a lot of these opportunities to learn about STEM so early in my career. And the fact that STEM school even exists is just mind blowing to me. That there's so much focus on learning so much about STEM so early, because it will help you long term. Just to figure out what do I like, what do I like better, and guide your career. So being able to get involved with the STEM mentoring, to me, is very personal, specifically, STEM at Highlands Ranch. I think my first event was Code Quest, where just STEM Highlands Ranch took almost all the trophies. So there's a lot about the preparation that the instructors and the teachers and the administration put in. And it's surreal. I see myself. And the surprising thing is that so early in high school and in middle school, they're learning about designing missions or concepts of operations, or what are the key variables that drive the design of a spacecraft or a rocket, where I had no idea until I got to college. So it's shocking and just surprising, the amount of knowledge that the students already have, and so beyond prepared that they are at such an early stage, and that will help them unimaginable ways down the road that they may just not realize right now. But being just part of that, first fundamental stages of like asking them questions and then them doing their research and coming back to you and totally surprising you about considering all these variables, is just amazing to me that they know so much so early.
Now, you're such a busy individual with so many projects going on. How much time are you able to dedicate to the program, and what are you hoping to get out of it moving forward?
Yeah, we're fortunate enough to we make the time. At Lockheed Martin, just outreach to the community and just inspiring that next generation of explorers and scientists, and engineers. It's extremely important. We need the talent, right? The universe is big. There's a lot to explore. So we're fortunate enough that we just, it's a blessing to be able to give back to the community in STEM. We meet every week with the students to work on their project. In fact, we have another meeting today to talk about the concept operations and where they're at. So, I try to tell the students like, hey, yeah, sure, we're professionals or whatever, we may be busy, but reach out. Like, you have our emails, you have our contact information. Don't get stuck, because the reality is that sometimes we get stuck and we need help from other people. You will never know it all. So I try to encourage them to just like, hey, here's some resources, reach out if you get stuck, we'll help you out. So yeah, we try to at least at a minimum an hour, but we always tell them like, we're open. Reach out if you want to have another meeting or a quick tag up or learn about this part a little bit more or less. And not only that, we tend to talk a lot about the technical details, but just life at work and work-life balance, and salaries and all the benefits of working at different companies is another conversation that we try to have with the students, because it's a big part of your career and your life and the growth in the industry, to know those details as well.
And that leads me to my next question. If there are students watching this who are interested in going into the space industry, or engineering or thermal engineering or aeronautics. How does that industry look currently? Are there a lot of opportunities? Is it something that they should consider?
Oh, it's surreal how much the industry is evolving. You have commercial companies, not only, the Lockheed Martins or the Boeings of the world, you have other companies that are coming to fruition like SpaceX, and there's a lot of tourism too that there's been talked about. And you can also see not only on the human spaceflight side, but launching astronauts to commercial space stations. There's so much. The industry is evolving so quickly. Right now, I'm working on Lunar Trailblazer, which is actually a small sat. So we're trying to do more things with CubeSats and smaller size spacecraft that are more cost effective to do deep space exploration or studies here around orbit on Earth, to learn more about Earth and the climate and the environment change. There's so many opportunities with like small sats now and just commercial companies. So the industry is growing significantly. We always, talk about engineering or science, but you don't necessarily have to be, specifically an engineer or a scientist to work on these missions. We have communications professionals, we have finance, we have human resources. So the opportunities are out there to work in STEM in so many different ways. So start early. You have all these resources, like STEM at Highlands Ranch. You have the connections to the industry professionals, at Lockheed Martin and other places. So start early, and it's not so much like we all have this path set. Like, here's all the steps that I need to take to get to my target job. It's a discovery about what you like and what you don't like. So just start that journey early and talk to mentors, talk to your teachers. My science teachers and math teachers were just so supportive in encouraging me to like just challenge myself. I was never always that good kid at math and science, but they just kept challenging me, and it's possible. It's possible to work in the industry, and I'm proof of it. There's so many other of my colleagues that have so many different stories of like weird paths to get to this point, and just start finding what you like and what you may not like as much early, and just keep going. The industry is just evolving, and you can be part of the future. You can be part of missions that, like Lucy, that are flying right now. You can be part of that flight operations team, eventually. It's definitely possible.
Now, my next question is one that I have personally, because it's not every day that you get to talk to a deep space exploration engineer. And my question has to do with Mars. Our kids are in the middle of doing a Martian greenhouse project where they're trying to figure out a solution to the problem of growing plants on Mars, because in the event that we send people there, we send astronauts there, they're going to have to eat. We're going to have to see if plants can grow on Mars. And so my question to you, if you were talking to a group of STEM students right now, curious about, in your opinion, do you think that in our lifetime we will see a manned mission to Mars? And do you think that plants can grow in that environment, in your opinion?
Yeah, yes, and yes. It's definitely possible. Mars has the atmosphere that we just need to figure out how to extract, like a CO2 from the atmosphere, convert it into oxygen, right? So it's a terrestrial planet here like Earth. There's gravity, which is important for our bones, et cetera, right? We have missions, this robotic missions out there right now that I was talking about, that have been mostly driven with the search of water, right? We know, that there are some deposits of water ice on the pole caps. There's believed that there's deposits potentially of liquid water under the surface. There's a lot of research going on right now. Yes, it is within our lifetime. At Lockheed Martin, we believe that the first person that's going to land on Mars, it's probably middle school or high school right now. So the technologies are there. It could be one of you, right? And it's so amazing that we're talking about the resources that we're going to need to support human presence of Mars all these little technologies and things are still in development, and just the students being involved in these concepts are real problems and challenges that NASA and the industry are working on right now. So we need everybody's creative, diverse solutions to these challenging problems. So it's so cool that folks are working on these kind of projects right now. Yes, it is possible. It is likely going to happen in our lifetimes, and it's probably going to be a student in middle school and high school, the first person to step foot on Mars.
And you know what? It could be a student at STEM for all we know. So, so the mentoring that you're a part of and so many others are part of, it's so important. We greatly value it, Will, and we also greatly value your time. I could sit here and talk to you for hours about outer space and planetary exploration, but I want to be respectful of your time. However, I do want to check back with you on the projects that you're working on and the mentoring that you're doing with students, if that is okay with you.
Absolutely, Jeff. Yeah, my pleasure. And again, thanks to the teams at Highlands Ranch STEM. Just the students don't cease to surprise us, and it's kudos to not just the team, at Highlands Ranch and the teachers, but also the parents that just invest time in their students. And as I said, we need the talent. We need you. so keep learning and keep trying, and it is possible. You have so many resources out there, and happy to help anytime.
Very exciting times. Will, thank you so much.
Thank you, Jeff.